So the next topic we are going to see is, suppose, let's say there is a conductor again, electrons are there, positive terminal, negative terminal, and there is an electric field in this direction. If this is going to be the length, if L is going to be the length of the conductor and A is going to be the area of cross section. So we know that I is equal to NEA into VD. Right. So let this be equation number 1. But what do we know about drift velocity? So we know that drift velocity is equal to small e into capital E divided by m into tau. Right. So let this be the second equation. So I'll take this expression and plug it here. If you observe, I didn't put a minus sign here because I'm only concerned about magnitude. Minus sign is used only when you need to speak about direction. So here everything is drawn, so I didn't use it. I is equal to NEA into, observe. In the place of VD, can I write it as E into capital E divided by M into tau? Right. So let this be the third expression. It is a combination of first and second. But what is a relation we already know that is existing between electric field and potential difference? So we know that electric field is equal to the negative of potential gradient, but since they have already drawn the direction here, and you know the potential difference that is existing between positive and negative terminal, if I say that the potential difference existing is V, can I write E is equal to V divided by L? Right. So if I take this to be 4, can I take this and plug it here? So the logic is simple. First, I wrote the expression for current. Second, I wrote the expression for drift velocity. I combined both. Then you got a third expression for current in terms of electric field. I'm using a known relation between electric field and potential difference. Now I'll take this 4 and put it into 3. So you will get another equation like this. I will be equal to NEA. I'll take this E here divided by M into, I'll have this tau also here. In the place of E, I will replace it with V divided by L. Right. Now I'm going to rearrange this equation, which implies I'll keep this V here. So I'm just writing this V on the left hand side. Okay. So V is going to stay at this place. Now what will happen is all other parameters will get shifted to the right. So V will be equal to M into L, because M and L are in the denominator, go to the other side. M into L divided by N into, observe. E into E is going to be E square. A is A only, and the tau will go to the denominator. The whole thing multiplied with current. So this whole thing is going to get multiplied with current. So if you observe this expression, this whole thing can be replaced with a symbol R, which you already know in the name of resistance. So this is the expression for V is equal to IR, which is nothing but your Ohm's law. So in your 10th grade, you learned this as Ohm's law, right? Now we will see why Ohm's law is defined in that way. So how does the statement start? It says when the temperature of the conductor is a constant, right? When the temperature of the conductor is a constant, the current flowing through the conductor is directly proportional to potential difference. Okay. In some books, they will say that the potential difference is directly proportional to current. That is wrong. Because anything that is proportional should always be a dependent quantity. Here, current is the one which is dependent on the potential difference. Try to understand what I'm saying. Current is getting generated because of the potential difference you connect. But the potential difference value is not getting generated because of current. Means you go to a shop and buy, the potential difference is fixed. You buy a battery, its potential difference is fixed. If you connect a 1.5 volt battery, there is a specific amount of current that can flow. So current is controlled by potential difference, but the reverse is not happening. That is why I'm stressing on this point. Make it a practice that whenever you're defining proportionality things, make sure left hand side should be a dependent quantity and right hand side should be an independent quantity. Okay. So here what is happening is current is directly proportional to the potential difference provided what? The temperature is constant. Why they are saying it is because we write V is equal to IR and you introduce this R as a constant of proportionality. Now we will understand when you look at the actual meaning of R. When temperature changes, since conductors are metals, when you supply heat to it, they expand. So L will change. Similarly, what can change? A will change. And most importantly, the relaxation time will change. Because when you supply temperature, the kinetic energy of the particles will increase. I repeat, kinetic energy increases. The time existing between two successive collisions will decrease because they start moving faster. You're able to understand? So this expression is what is Ohm's law. So we have seen the derivation of Ohm's law.